Hello viewers, we're taking you through this tutorial for O-level mathematics contest questions. So in this video, we're going to go through the possible solutions for the internal junior mathematics contest for the year 2023, which was held at Ndejje Senior Secondary School. So this contest was school-based and aimed at selecting students who will represent the school in the national mathematics contest. I think you are aware that in Uganda, the Uganda Mathematical Society prepares national mathematics contests, of which the best students can represent the country in the East African Mathematics Olympiad, known as IAMO, and Pan-African Mathematics. So East African, you represent the country and you compete with East African countries. Then Pan-African Mathematics Olympiad, they represent the country and they compete with all African countries. Then International Mathematics Olympiad, they represent the country and they compete with all countries in the continents of the world. So this contest was for Senior 1 and Senior 2. So this term, the next term, the best here will compete with the Senior 3s, of which we shall get those who will do the O-level national mathematics contest. So in this internal mathematics contest, we had top 8 students which were outstanding, of which 7 were in the second position. So there was a tie of all these 7 students in the second position, and the first position was only one person. So Sikawa is this first one. So the first one is the patron of the mathematics, this is the president of the mathematics club called Kamegia, followed by Sikawa Nathan, Senior 1A, then Katongoli John Peter, Senior 1B, then Ayeta Abigail, Senior 1B, then Bagenda Jordan, Senior 1E, Serugunda Edward, Senior 1E, Mangeni Isaac, this is Mangeni Isaac, Senior 2A, and Namagambe Desire, Senior 2A, and lastly Rasa David Rasa Muksa Jonathan, Senior 2D. So this is the patron and I'm the one. So the best were given medals, as you can see here, and also certificates, and the overall best was given a trophy. So I think realize that there are only 2 girls in the top 8. So one is in Senior 1 and one is in Senior 2. So the one in Senior 1 became Miss Math of Senior 1, and that is it. That is her. Then you also have Miss Math Senior 2, and we have also the overall best student, and that was Rasa. He got a trophy and he was in the first position. So this is a sample of the certificate of merit, where those who were outstanding, those who were outstanding got. So the total was 450 students, and the best will compete with the Senior 3s. So that was a brief highlight. We can now go to the solutions, or the longer awaited. So this math contest was divided into 3 parts based on the age bracket of those who attempted the paper. So the first part was logic and reasoning. So we are interested in how students reason mathematically. So this part A had 6 questions. Actually, it carried the most marks. Then part B, there was also part B, which involved number theory, and part C, which involved algebra, as we shall see. So in this video, we are going to go through the part solutions. Actually, we call them possible solutions because there may be various ways in which a student can reach the answer. So what I will give you is just a possible approach to the answer. So question 1 says, Dennis Henry, Jack, Martha, Ronald, and Tom were in a 12-person race with 6 other people. So these are 6. There is 1, 2, 3, 4, 5, 6. And when you add on these 6 other people, you get the 12. Okay. Then they said Ronald finished 6 places ahead of Henry. Okay. Martha finished 1 place behind Jack. Okay. Dennis finished 2 places behind Henry. Okay. Jack finished 2 places behind Tom. Tom finished 1 place behind Ronald. Martha finished in the 6th place. Who finished in the 8th place? So let's try to go through these questions step by step. So we shall go through each statement and analyze it and see how we can arrive to the final answer of who finished in the 8th place. Let's start with the second statement, because the first statement was about listing the people who participated in the race. So the first statement says Ronald finished 6 places ahead of Henry. So we are going to come and draw a box of Ronald, and then we count 6 places. 1, 2, 3, 4, 5, and 6. So this is where Henry is, because Ronald is ahead of Henry 6 places. So we don't know who are in these places. That's why we have left them blank so far. Then shall go to the next statement. Next statement says Martha finished 1 place behind Jack. We don't know where Martha was in any of these. So what we do, we shall come and draw other boxes and put there Martha and Jack. So Jack is here, Martha should be behind. 1 place behind. Okay. Then the next statement says Dennis finished 2 places behind Henry. So the good thing, we know where Henry is. So we are going to come and say, let us first redraw this and we locate where Henry is. So from here they said 2 places behind Henry, so you count 1, 2, and that is where Dennis is. Okay. Then next statement said Jack finished 2 places behind Tom. The good thing, we have Jack here, so what we are going to first redraw and then we see where Tom is. So Jack is behind Tom. So if Tom is here, you count 1, 2, and that's where Jack will be. Okay, but we don't know where these 3 are in this box. Let's go to the next statement. Next statement says Tom finished 1 place behind Ronald. Okay, now what we are going to do, we are going to carry all these 4 boxes and they will fill these 4 places, because they said Tom finished 1 place behind Ronald. So this Tom is here. So this will be blank. Jack will fill this and Martha will fill that. So let's do that. So that is what we have so far in step 3. Then we shall come and put Tom, Jack, and Martha. Tom is here, Jack is here, and Martha is there. So these are already 1, 2, 3, 4, 5, 6. So those are the 6 names which we are given. Now we have arranged them. Then we shall go to the next statement. The next statement says that Martha finished in the 6th place. So what you're going to do, you're going to redraw the boxes in step 5. Then we ask ourselves, if Martha finished in the 6th place, then 7th place should be here, whose name was not given, and 8th place will be here, and that is Henry. Therefore, we shall conclude that the person who finished in the 8th place was Henry. So that is one of the ways you could attempt such a question. Now we shall go to question 2. Question 2 says, a politician A lies on Mondays, Tuesdays, Wednesdays, and tells the truth on other days of the week. Okay. Politician B lies on Thursdays, Fridays, and Saturdays, and tells the truth on the other days of the week. Okay. One day, both of them say, yesterday was one of my lying days. Okay. What day is it when they say this, if one says the truth and the other says a lie? So there could be other ways of attempting such a question, of approaching such a question, but one of the ways will be to tabulate. Then you put all the days of the week. We shall put politicians, then they put the days of the week. This is just a repetition, because from Sunday we know that we go back to Monday and so on. Now we are told that politician A lies on Mondays, Tuesdays, and Wednesdays, then tells the truth on the other days. So other days we shall put truth, truth, truth. Now here I've put lies because it is just a repetition of this. That is politician A. What about politician B? Politician B lies on Thursdays, Fridays, and Saturdays, and the other days it tells the truth. Now when you analyze that table, there is something you are going to realize about politician A, and that you realize that the only days that politician A would make that statement will be Monday and Thursday. So if you isolate Monday, which is here, and Thursday, which is here, those are the 2 days in which politician A would make a lie, would make such a statement. Because here, truth, lies. Even here, lies, truth. Okay. That is politician A. What about politician B? Politician B, there is also something you realize, that he can make such a statement on Thursday and Sunday. Now let's analyze this Thursday. Do you see? Here there is lies and here there is truth. What about Sunday? Sunday, here there is truth, here there is lies. So that's why you chose these 2 days. Okay. Now, the day which intersects for both is this. You see Thursday and also Thursday. Now let's analyze this Thursday. So Thursday, you realize that one is telling the truth and the other is telling a lie. Because politician A actually told the lie yesterday on Wednesday. And politician B actually told the truth, but is telling us that yesterday was one of his lying days. So the day when this was spoken must be Thursday. So that is what they wanted in that question. Then we shall go to question 3. Question 3 says, some chocolates are missing, and one of the 3 children ate them. At least one child told the truth, and at least one lied. Okay. The children made the following statements. 1. John said, Mary did not eat them. Okay. Then Mary said, either John or Tom ate them. Okay. Then Tom said, John ate them. Now the question is, who actually ate the chocolates? So such a question is also easily done by tabulating. So questions which involve truth, false are easily done by tabulation. So we are going to come here and draw a table. Like I said, this is just one of the possible approach. Remember, each of the three made the statements. So we are going to analyze each of the statements where one told the truth. Now here we are saying, now this statement, this column says, if John ate the chocolates. What we are meaning is that if it is true that John ate the chocolates, which of the statements is true and which of the statements are not true? So let's go and analyze, bearing in mind that we are assuming that John ate the chocolates. So John's statement, Mary did not eat them. So it is true because it is John who ate the chocolates. Remember, we are assuming, okay? Then Mary said, either John or Tom ate them. This one is also true because John ate, and they are saying the word "oh." Okay, then Tom, John ate them. It is true because we are assuming that John ate the chocolates. So we shall come here and put true for John's statement, true for Mary's statement, and true for Tom's statement. That was assumption that John is the one who ate the chocolates. Now, what if it is Mary who ate the chocolates? Let us also analyze these statements. So if it is Mary who ate, John said, Mary did not eat. So John will be telling a lie, because we know that Mary ate in this assumption. Then Mary said, either John or Tom ate them. So this will be telling a lie because she ate them. Then Tom says John ate them. This will also be a lie. So all are false. So you come here and say that let us fill false for John's statement, false for Mary's statement, false for Tom's statement. Okay, now the last option, what if it is Tom? So this is a spelling error, but this word is Tom. What if it is Tom who ate the chocolates? Let us go back and analyze their statements. So John said Mary did not eat them, so it will be true because it is Tom who ate. Mary said either John or Tom ate them, so it is true. Okay. Tom said John ate them, so it is false. Therefore, shall come here and fill in that true for John's statement, true for Mary's statement, and false for Tom's statement. But the question said, here they said, at least one child told the truth and at least one lied. So here you realize that for this first case, all of them told the truth. So this is off. It is not John who ate. Second case, all of them told the lie, meaning it is not Mary who ate. But here, there is one false and one told the lie and two told the truth, meaning it is this, because it satisfies the conditions given. Therefore, we shall come and conclude. Okay. So there's a contradiction for John, also a contradiction for Mary, and therefore the person who ate them was Tom. So that was question 3. Now question 4. If the 14 blocks below must be filled with whole numbers, so that the sum of 3 consecutive blocks has a total of 18, find x. Now this one had a little logic in that the number, for example, if this is A, okay, let's say if this is A, B, C, okay, but they told us the sum of 3 consecutive has a total of this. So for the sum to be constant, it means that the next value should now be A, such that if I add this, it is A plus B plus C. Okay, what about when I add this? It should also be A plus B plus C. The next value will be B, so that when I add these ones, it will be still A plus B plus C, like that. So what do we realize? That the values keep on repeating each other. What you remove from here is what goes here. What you get from here is what goes here, like that. So that was the logic behind this question. The logic is that for the sum of each 3 consecutive values, it means that the value put in the next box should be equal to the value of the box discarded. So if I put here A, B, C, when I remove this and I take up the next, it should be this, so that this is also a sum of A, B, C. Do the same for this. When I remove this, the remaining part is the sum of A, B, C. Remove this, add another one, the sum is A, B, C. So we realize that the sum is constant for any 3 consecutive numbers. So we shall do that for all boxes. When you do that, you will realize that A is equal to 7, B is equal to X, and C is equal to 8. So we shall come here and say that A is 7, B is X, and C is 8. Then we shall come and remember what was given in the question, that the total of 3 must be 18. So A plus B plus C is equal to 18. I know A, substitute. I know B, substitute. I know C, substitute. Then I'll add this plus this gives me 15. Okay. Then next will be to make X the subject. I'll take this 15 this side to come up with 3. So 18 minus 15 gives you 3. And that's the value they wanted. Question 5 says, a 3 by 3 magic square consists of 9 different numbers placed in a grid in such a way that the sum of the numbers in each row, each column, and the 2 main diagonals is the same. The numbers 5, 10, 15, 20, 25, 30, 35, 40, and 45 are used to form a magic square. Some of these numbers have been placed as shown. So 20 has been placed, 45 has been placed, then we have A, which is unknown, B, X, which is unknown, and Y, which is unknown. Find the possible values of X and Y. So what we need to remember is that the sum of numbers in each row, each column, and the 2 main diagonals is the same. So this is equal to this. But the question is, what is the sum for each row and each diagonal? So here the trick was that you add all the 9 numbers and you'll get 2 to 5. Now those 9 numbers, this is what will happen. If you add these plus this plus this, you are going to get 2 to 5, which you have got. But they say the sum is the same for all, meaning this is the sum here is the sum here and is the sum here. So when I get that total of 2 to 5 and divide by 3, I'll get the sum for each row. So that is what I'm going to do here. So total sum for each row is 225 divided by 3 to give you 75. Okay. Now in that 75, here I'm given two values. So when I add 20 plus 45 plus A, I must get 75. So I'll come here and say that for the first row, 20 plus 45 plus A is equal to 75. So when I make A the subject, it will be 10, because this is 65. Then take the 65 this side, it will be 75 minus 65 to give you 10. Now I've got the value of A. And this sum is equal to this sum for the column. So A plus X plus Y is also equal to 75. Therefore, I'll come here and say, for the last column, A plus X plus Y is equal to 75. I know the value of A, I'll come and substitute. Then take this side to come up with X plus Y equal to 35. Okay. Now from there, you'll ask yourself, how many are remaining? Remember, 20 was removed, 45 was removed, and this has been removed. So you're left with 5, 15, 25, 30, 35, and 40. Okay. Now of those ones, which pair can give a sum of 65? You realize that there's only one pair, which when added you get a sum of 65. That means that X plus Y, that means that if X is 30, Y will be 35, and if X is 35, Y will be 30. And that's what they wanted. Now I shall go to question 6, which said, arrange the numbers from 1 to 9 in the 3x3 grid below so that each number occurs once. Okay, the product, that is multiplications, the product of entries in the first row is 12. The product of entries in the second row is 112. The product of entries in the first column is 216, and that in the second column is 12. So let's look at a possible solution to this question. The first step, because they taught about products, you are going to prime factorize each. So you are going to come and redraw the grid. Then you remember that the first row, it was supposed to be 12, so you prime factorize it. Second row was supposed to be 112, you prime factorize it. First column, 216, you factorize it. And second column, 12, you prime factorize it. That is step 1. Now this step means that all entries here must come from this, and entries here must come from this. Entries here must come from this, and entries here must come from this. Except 1, because 1 times any number, it remains the same number. So that means that it is 5 which is not appearing anywhere, and it can't occur in any of this, and any of these too. So 5, it means it only appears there. What about 7? 7, it can't appear here because if you look at this, there is no 7. It can't appear here because when you look at this, there is no 7. Meaning this 7 must only occupy that. So that gives us step 2. Step 2 says from the given list, 7 can only take position R2, C3, which is this. So let's do that. Then also 5 can only take position R3, C3, like I've already told you, which is that. So you have succeeded in filling 2 places. The rest we shall now go to step 3. Step 3, now the remaining list. From these ones, we are going to remove 7 and 5. This is what to remain with. Okay. Now from there, let's analyze row 2. This row 2, we're analyzing row 2 because at least we have one value here. Now we need only 2. This one we cannot because we don't have any information here, and what we have is for these columns. So let's start with row 2. What should be here and what should be here? This 7 has already gone here, meaning these two places must have a product which is equal to 2 to the power 4. So the product should be equal to 16. And that 16 is 2 times 8. Because we're using 2 times 8 because if we say 4 times 4, it means 4 will be repeating itself. Yet they want each value to appear once. So we can't use 4 times 4. The only option is now 2 times 8, which is this. Now the question is, where are you going to put 2 and where will you put 8? If I put 8 here and 2 here, does it make sense? You will realize that here in this product there is no 8 because 2 to the power 2 is 4, meaning 8 cannot go here. So the only value of the 2, the value which can go there is 2. So it is supposed to be the other way around. 8 should be here and 2 should be there, because here at least we can get 8 there. So that is what step 2 gives us. So step 2, 8 cannot take this position. Therefore, since this one, since this there is no 8 here, like I've already told you. So what will happen? 2 will take this and 8 will take that. So let's put them there. So we shall put 2 and also put 8. Okay. Now row 2 is entirely complete. We can now go to other rows or columns. So this is what we had in the previous slide. So I've just copied this and wrote it here. And that will take us to step 4. Step 4, the first thing to do is to find out how many digits are remaining. We're remaining with 1, 3, 4, 6, and 9. Now let's analyze this column 1. This column 1, the 8 has already gone. So you are left with 3 to the power 3, which is 27. That 27 is now 3 times 9. That's the only product we can get to fulfill these conditions. So the question is, where should 3 go and where should 9 go? If I put 9 here and I put 3 here, does it make sense? You realize that here in this product, 9 does not exist. So the only option is to put 3 here and 9 there. So let's do that. So we can now put 3 there and also put 9 here. That is step 4. Okay, now what about step 5? Step 5, we are going to analyze now this column. So, but for that we have to list down the remaining values. We have 1, 4, and 6. So we are going to analyze this column 2. So for column 2, if this 2 goes away from here, we shall now be left with 2 times 3, which is equal to 6. Okay, and 6 is here. So we are left with 6 to fill this and this. And also for this row, we are left with, remember 3 has already gone. So we are left with 4 to fill this, and this. So that means that this common part must have 1. Then this will have 4 and this will have 6. Hope it is understood, because 4 times 1 gives you 4, which is here, and 1 times 6 gives you 6, which was here. So that is how this puzzle, okay, that is how this magic square or the grid was supposed to be filled. 1 there, 4 there, and 6 there. It involved some reasoning, but the good thing is that some of the students were able to get it correct. So that brings us to the end of part 1. Be reminded the next part B and part C, their solutions will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student interested in math contest questions and is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.